Okay, welcome back. So today we are going to talk about establishing an identity. We're going to try to show that the left side is equal to the right side. Um, pretty much what establishing an identity means. So from the left side, this is the equation that we have. Now you could have easily started with the right side, but I think that's a little bit harder to go about going from the right to the left. So from the left side right here, there are many different approaches that you can have taken here. But the best way I think for us to do is to go ahead and try to make it so that it'll have a tangent on the right side. So pretty much I already have a tangent here. So I will probably just go ahead and change cotangent to tangent. So this is what we're going to do. We're going to keep the top. I'm going to use my basic identity for cotangent, and I'm going to switch that to 1 over tangent. So this is using basic identity, pretty much the reciprocal identity. Okay, so now what you want to do once you do that is let's go ahead and try to add the fractions on the bottom. So you need a common denominator. So add fraction and find common denominator. Okay, so on the top, we'll still have the same thing, 1 plus tangent u. On the bottom, the LCD in this case is tangent. So we're going to say tangent over tangent. So tangent u over tangent u, that's 1 plus 1 over tangent u. Now you can actually add it. Okay, on the bottom, when you add it, you should get tangent u plus 1 over tangent u. Okay, so that's just adding the fractions. Okay, what you want to do next is write it as your normal division problem. So I don't like to write it like this. When you have a fraction over, well, if you have a numerator over a fraction, we tend to write the fraction like so. So we're going to go divided by tangent u plus 1 over tangent u. So this is just rewriting it. Right, so rewrite. So after you rewrite this, now let's go ahead and multiply by the reciprocal. So multiplying by the reciprocal, instead of doing division, we multiply by the reciprocal of the second term. So that's just tangent u over tangent u plus 1. And then over here, let's have tangent come before the 1. So we're going to just switch places. And this is over 1. When you multiply, you just cancel. So we're going to cancel like terms. And notice these two are the like terms. So what I end up having is just tangent u, since the tangent here crosses out with this one. Alright, so now if you look at it, we went from the left side, which is right here, and we end up with the equation tangent u on the right side. So that shows how you can go from the left to the right. Okay. Let's try out a different set of problems. So the next one is this type of problem right here. For this problem, it's done almost pretty much the same fashion. Whenever you have a fraction adding to a fraction, we have the tendency to always start with adding fractions. So let's start with the left side. So on the left side we have sine theta Alright, so again, this is my left. I want to arrive to the right side. So let's go ahead and find a common denominator. So LCD, find LCD. So once you find the LCD, which in this case is just sine theta times 1 plus cosine theta. So you're just multiplying these two. So let's go ahead and multiply the top and bottom by, in this case, you're going to multiply this by sine theta, just so that we can make the LCD, the denominator here, the LCD. So you do that to the top as well. Alright, and then on the right side, which is this side, let's see, what else are we missing on this side? So on this side right here, it looks like I'm missing this chunk right here, which is a 1 plus cosine theta. So I'll do it to both sides, top and bottom, I mean. Okay, so now what we want to do is, since the denominator is the same, you can go ahead and multiply these two right here. So you just have sine square theta. And then this one right here, just distribute. So we're just going to distribute then as the next step. Okay, so multiply this. You get 1. 1 times cosine is cosine theta. Cosine times 1 is cosine theta. And then cosine times cosine is cosine square theta, all over this bottom portion right here. We'll just keep it the same. Okay, so now the next thing after you do this is combine like terms. So let's go ahead and combine like terms. So in combining like terms, we got sine squared theta plus cosine squared theta. I'm going to reorganize those two first because I see a relationship here. And then I get a plus 1, and then cosine theta plus cosine theta is 2 cosine theta. And this whole thing is over your denominator. Okay, so the next step after this, after we combine like terms, now I'm going to use the Pythagorean identity. Alright, so that Pythagorean identity, sine square theta plus cosine squared theta, that's 1. So that, you just replace that with the 1. Everything else stays the same. Okay, let's go and simplify. So 1 plus 1, 2, plus 2. So all I did here was just simplify, and then I look at it and I say, alright, well, let's see this. There's a 1 plus cosine, and I notice there's a 2 and a 2 here, so I'm going to factor. So I'm going to factor the top, factor the numerator. I get 2, factor that out. Get 1 right here plus cosine theta. And then everything else stays the same on the bottom. And because I was able to factor this, I'm going to cancel out like terms. Cancel out like terms. And it looks like the two like terms are these ones. 1, 2. We cancel it out, and we're left with 2 over cosine. Oops. We're left with 2 over sine theta. And let's see if that's what we need to get. Not quite. It wants me to get 2 cosecant theta. So I have one more step to do. So that last step is using my identity, basic identity, which is the reciprocal. The reciprocal of this is just 2 cosecant theta. So that is my right side. Alright, so we went from the left to the right. Let's check it one more time. I went from my left side, and I did arrive to my right side. Yep, that is it.